Water is life everywhere on our planet. Here in South Africa, where freshwater resources are scarce and demand continues to grow, water is particularly precious.
So, where does the water come from? And where does it go? And how is it used? And how can we protect and better conserve this vital resource that is so essential for all of us, as well as for our nation's growth and development? I'm Errol Felix, and I'm going to take you on a journey to explore the movement of our fresh water, starting right here at the picturesque Jonkershoek Valley in Stellenbosch. Let's start with our freshwater resources.
Earth is often called the blue planet because 70% of its surface is covered by water. But out of all that water, only 2.5% of it is fresh, and the rest is salty seawater. And fresh water is what is needed for the domestic, industrial and agricultural uses of Earth's current 6.8 billion people. Thus, it is our freshwater resources that are critical.
Most of us recognize springs, rivers, dams and wetlands as freshwater sources because we can see them. The rain falls from the sky and pristine mountain streams like this fill up and feed larger rivers downstream.
Or rain falls from the sky and farmers build dams to trap the surface rainwater runoff and store it. Rain may also flow to wetlands, which then hold the water and provide many benefits such as flood control, natural cleansing of water, and groundwater recharge.
However, few of us realize what an important resource groundwater is. When rain infiltrates down into the soil, some of this moisture is taken up and used by plants, while some infiltrates deeper into the soil and recharges groundwater.
Even though we can't see it, the water stored below the ground is where much of the Earth's fresh water is to be found. 30% of it, in fact, about 100 times more than the fresh water to be found in rivers, lakes and dams.
Believe it or not, but I'm walking on top of a huge body of water. This borehole can pump up to 10 liters of water per second from the ground below, enough to fill the average household swimming pool in just about an hour. So, what does water look like underground? Mostly, groundwater is less like a river and more like water held in a giant sponge. Much like this one, it occupies the spaces between the soil particles in sandy aquifers and occupies the space within the network of fractures in rocky aquifers. The water cycle gives us the big picture of the movement of all the Earth's water.
Keep in mind that the global water cycle is a closed system. In other words, the total amount of water in the world is always the same and hasn't changed much since the time of the dinosaurs, but it is continually cycling. Water falls from the sky as precipitation. Some of this water infiltrates to underground aquifers. and some of it flows as surface runoff into streams and rivers. The upward cycle of water back into the atmosphere occurs through evapotranspiration by plants, as well as simple evaporation fueled by the drying effects of the sun and wind.
The critical challenge to the water cycle posed by climate change is that increasing amounts of water are being lost to the sea.
This is occurring because of melting ice caps, as well as the changing nature of global weather patterns. Rainfall has become increasingly erratic, as well as more extreme in many parts of the world. During extreme rainfall events, there is a greater percentage of surface runoff and less chance for water to infiltrate into the ground. Losing fresh water to the sea is not always a bad thing. It is also part of the natural water cycle. The fresh water from rivers that mixes with seawater in estuaries, for example, is necessary for sustaining these vital coastal ecosystems.
However, the result of climate change is that a growing percentage of the Earth's water is becoming saline and freshwater resources are becoming less. And all this is happening while the demand from a rising industrialized global population continues to grow, putting more and more pressure on these resources. The careful management of our freshwater resources is critical if South Africa is to sustain growth and development. Now, the key aims of water resource management are to slow down and to store the surface runoff that results from rainfall and to recharge groundwater aquifers.
These are processes that happen naturally in wetlands, but that need to be managed more broadly. In South Africa, integrated catchment management has been identified as the method for managing freshwater resources. A catchment refers to an area that collects surface runoff based on the geography of land that naturally drains surface runoff to a common area. Catchments need to be managed as a whole because of their interconnectedness. An activity in one area can affect the water in another.
The different types of rainfall environments found in South Africa largely determine the focus of water resource management.
In an arid environment like the Karoo, rainstorms happen once every few years. Most of the rain falls in distant mountains and then comes through the Karoo in the form of flooding rivers. Because of the sandy soils, infiltration is good for the short period of the flood. These floodwaters are the main source for recharging underground aquifers. Groundwater, accessed by boreholes, provides most of the fresh water used in these catchment areas. In a summer rainfall area like the Eastern Cape, torrential rain comes pouring down the mountains with little time for infiltration, filling streams and rivers and recharging mountain springs. Rainwater harvesting takes place, with rain being diverted into rainwater tanks, small homestead dams and gardens, as well as larger livestock dams. Water supply schemes to rural villages consist primarily of capped mountain springs or weirs built on rivers to take off some of the flow for domestic use. larger towns often depend on municipal dams filled by surface runoff. Winter rainfall areas like the Western Cape have long, hot, dry summers and no rain when it is most needed. Here, growing water demand is dependent on winter rains to fill up dams and to recharge aquifers for the dry days of summer ahead. As a result, pressure continues for more and more investment in infrastructure.
Improving the collection and storage of rainwater is the common goal in the various environments. What is different is whether that collection and storage happens above ground in dams and reservoirs or underground in aquifers. So, when we talk about pressure on our freshwater resources, where is this demand coming from?
Of all the water used by humans, 13% is used by domestic households, 19% by industry, and almost 68% is used by agriculture. 1,000 tons of water is required to grow just 1 ton of grain.
Think about what that must mean when that grain is simply used to feed livestock and not people.
However, the more countries industrialize, the more water they use, increasing the percentage of water used by industry.
We've already talked about the movement of water in the natural water cycle. But what about the water that comes out of our taps? Where does it come from? And more importantly, where does it go?
You may be surprised to hear that water is recycled and reused more than you might realize. For example, water that is taken from a river for the use of a town will be circulated into the town as water supply and taken out as wastewater. The treated wastewater from an upstream settlement will often be part of the water supply for a settlement downstream. Let's track the cycle of water use within this area as an example. The water extracted from the river in the nearby mountains here first needs to be stored. Then this water is purified before it comes into our homes and industries. This is particularly important when water is extracted from sources that may be polluted and when water is intended for human consumption. The purified water is then reticulated through pipelines to its various use points, including this street and home, but also to the nearby commercial and industrial areas. The wastewater from these different areas leaves down sinks, drains and toilets, where it is piped to the wastewater treatment plant. Here, water is processed so that it should be clean enough to return to the environment. However, while this cycle of water use may be in working order, it is not the whole picture. Informal settlements with inadequate water treatment and waste disposal are a challenge throughout South Africa. Furthermore, there are still many areas in South Africa that do not have formal wastewater systems, or even a piped water supply. Waste is then often washed into rivers by rain, or it may eventually contaminate groundwater.
Water conservation needs to become a priority for all users, domestic, industrial and agricultural.
While using less water in our own homes is something we can each take responsibility for doing, the current demands of industry and agriculture are bigger challenges. On a positive note, the drip irrigation now used by some farmers in South Africa, particularly wine farmers, is a far more efficient form of irrigation than traditional systems. Within industry, many textile factories have addressed water conservation by treating and reusing their water.
From all that we've considered so far, it is clear that the protection of our water resources must be a priority. Threats to water quality come from domestic, industrial and agricultural users, causing different kinds of water quality problems.
There are various contamination routes that can affect surface water or groundwater. Industrial or agricultural pollution that drains into our waterways are clear examples. Poorly designed, overutilized and improperly maintained wastewater treatment works are becoming a critical threat to many of South Africa's streams and rivers due to overflowing sewage. Less obvious, but with even more devastating long-term effect, is the threat of contamination to South Africa's groundwater through pollution that seeps into our aquifers. This can occur through the inappropriate use of pit latrines, chemical or industrial spills, growing landfills, or intensive use of pesticides and chemical fertilizers by agriculture.
The repercussions of water shortages and contaminated water on our health and on our nation's ability to grow economically are huge, and government on all levels needs to ensure the protection of our freshwater resources.
And here in South Africa, where freshwater resources are scarce and demand continues to grow, water is particularly precious.
And as the movement of water circles back to its beginnings, here we are, back in the Jonkershoek Mountains, where we started our journey together. So I return to say once again, water is life everywhere on our planet.